Welcome, I'm Ryan Hoger with TEC Tube, and today we're going to be talking about different types of filtration for packaged rooftop units. What kind of filters can fit in your rooftop? What kind of pressure drop can you handle? How to measure pressure drop? When to decide to change the filter? And some things we can do to even enhance them. All right, to actually check out our filters and see what kind we have and see if they're dirty and to change them and all those wonderful things, I need to open up the filter section on the unit. If you got a really nice unit, you have hinged access and it just pops right open. But most of the time you don't have that, so you need to have a nut driver or a drill to take all the screws out of this guy. And once you do that, then you'll have access to the filters over here. So this is our economizer. We have a separate video on that discussion, just so you know what that is in the picture here. But here's our filters in here. So I pull these guys out. Right, so I have two of them this exact same size, right? And on the side, I'll tell you what you have. I have a 16 by 25 by 2 inch, which is a pretty standard dimension, and I have two of them because it's a fairly small unit. If you get bigger and bigger units, you'll have more filters. You may have rows of them and columns of them. This filter is pretty low end. Like, I can literally see the camera through this filter. It's pretty low end. This is like the bare minimum that you possibly get. His job in life is not to give occupants healthy air. His job in life is to keep pieces of debris, like cottonwood from the trees or whatever, and pollen, from getting on this cooling coil. I don't want anything on the cooling coil because then it hurts my ability to actually cool your building. The filter's job is to keep the system clean. If you want to filter better for people comfort and for people health, you need to upgrade your filtering system. So that type of filter that we just looked at is pretty basic. You probably can't get much more basic than that. What we need to do if we want to catch certain things out of your air is we got to figure out how big the things are. So the units of measure we use is called microns. Not that you have to memorize that or anything. But the normal things that we measure would be 10 microns and 2.5. However, some things like viruses and bacteria are even smaller than that. For example, COVID-19, SARS-CoV-2, is about 0.125 microns. So it's a really small thing. We have filters that can catch that. We have to specifically pick filters to do that. So the top end filters would be a HEPA filter, right? And that's not really technically on the MERV rating scale, but it's kind of like, if it was, it'd be MERV 17 through 20. So really prime stuff. The normal filters that we deal with will be MERVs 1 through 16. That's our typical filters. The higher the number, the smaller the things it'll be able to catch, and in large quantity. So in order to catch SARS-CoV-2, we really need to be kind of at MERV 13 or higher, at least according to the folks over at ASHRAE. Most rooftop units can't handle a MERV 13, and hence we have this problem. So if you look at this MERV scale that we're showing you over here, to get the stuff that's really small, like the 0.125 micron stuff, we're gonna need to be like MERV 13, MERV 14. So the different types of filters that we have, right? This is a pretty decent filter here. It's pretty thick though. That's not gonna fit in that slot we just looked at in the rooftop unit. This is a MERV 15, it can catch a lot of stuff, but it's too thick to fit in a rooftop. Whereas you can find other high MERV rated filters that are much thinner, like only 1 or 2 inches thick. But in order to do that, they put even more material in the filter, which means the pressure drop goes way up. And a typical packaged rooftop unit cannot handle that. So we can look at a few different types of filters here, right? So this is not much better than the one we showed you in the rooftop unit. It's pretty primitive. It's a washable one, but just like that one in the rooftop unit, it's not gonna catch very much stuff. It'll be pretty minimal. It's not gonna catch bacteria. It's probably not gonna catch mold. In fact, to be honest, this filter was here in our lab for 12 years and I've never changed it because it doesn't do anything, because it doesn't catch anything. And it's got dirt on it, but not much, right? As I start getting to more densely packed material, like this one is not quite as dense as this guy, it's also not quite as thick. This would fit in a lot of rooftop units, but I'm probably gonna get like a MERV 10 or a MERV 11, which is good and better than most existing units have, but it's not gonna quite get you to that bacteria virus type catching ability. Whereas a HEPA filter, which is fantastic for things like hospitals and stuff like that, this guy has a lot of pressure drop, probably like an inch, which is way more than a typical rooftop can handle. So anything with a HEPA is off limits for rooftop units. Totally off the table. This kind of solution is something that we like a lot. This one's really tiny because it's just a little portable one that I carry around, but they come in all the different sizes that you would need to replace the existing size that you have. And this one actually has a 24-volt power connection on it. That's a low voltage connection, which means you don't have to run on conduit, you can run a simple cable. And when you open this guy up, it uses a combination of electricity and filter media. So it's the same kind of filter media we just looked at in the rooftop unit, but it's also got this electrical grid on it. So it charges stuff coming into the airstream let's say for example, a charge is stuff positive, and the other side, it's a negative charge, and positive and negatives always attract, so it helps cling things onto this guy. So this guy can have a low pressure drop with pretty basic filtration media, but get a fairly high MERV rating. This particular little guy right here is a MERV 13, which is pretty good considering that it has low pressure drop, like 0.15 inches of static, and it's pretty thin. So there are ways to get the high MERV rating and still be able to handle the pressure through a standard rooftop unit. Now we have the unit actually running, the fan's on, and we're gonna measure the pressure drop across the filter. Right now the filter is actually clean. So I got my manometer on here. I'm actually gonna use the 0 button on here to zero it out so I kind of have nothing going on at all. All right, so now I got basically 0 or 0.01, which is basically nothing, right? 1/100 of an inch. I'm gonna take one of my probes here. I'm gonna stick it on the inlet side of the air. Now I do have the door off when I'm doing this, and for this particular pressure test, that's okay, because I just want the differential across the filter. If I was testing my ductwork or something like that, then I would have a different mentality on this. But for the filter, because I'm gonna isolate that one piece, this is okay. My other probe, I'm gonna have to prop it over on the inlet, on the discharge side of the filter. So I want it after the filter, before the evaporator coil. That's hard on a rooftop because that gap is like this. So in my case, I have to stick it in here like this, kind of on an angle, and kind of like jam it up in there. So I'm gonna pull the filter open and get this guy angled in here. These are magnetic, so that helps a little bit. Put my filter back in place, not letting it pinch the hose, so there'll be a little bit of bypass there, but not a lot. And right now, if you look at my manometer with this brand new clean filter, I'm at 0.05 inches across that filter, which is pretty low. It's almost nothing. But that's a pretty low grade filter like we said before, and it's clean right now. So let's get that swapped out with the dirty filter. Now we have a dirty filter in here, and as you can see on our manometer, we're up to 0.29 inches of pressure drop. That's pretty substantial and well beyond what a normal rooftop can handle. Now, how do I know when it's too much? Well, I need to look at the specifications for that specific filter, and I should be able to get data on what the filter pressure drop is when it's clean, and for many manufacturers, what it is when it's dirty. And then also, as I learn systems, air handlers, furnaces, rooftop units, I kind of get a feel for what's normal and not normal. And 0.3 across the filter, 0.29 across the filter, that's a pretty substantial pressure drop, and that's a very, very, very dirty filter. I'm probably on this kind of low-end filter, 0.1, 0.12, I'm probably gonna change it. Now I might have other filters that have different specs and it'll be a different expectation, but this is definitely a dirty one. I'm gonna wanna swap that out. The last thought we're gonna leave you with is ways to improve your filter without actually putting in a different type of filter, right? There's ways we can make it catch more stuff by making the stuff physically bigger. So we have these things called bipolar ionizers in our industry, and they go out into this space, these ions do, and they're positives and negatives, so they make things clump together. So instead of something really small having to get stuck in the filter, things clump together, and now when they make their way back to the filter, they're larger, so they'll get stuck in the filter more easily. So that MERV rating we were talking about, if I do bipolar ionization, I'm gonna get 3, 4, 5 extra MERV points, if you will, by putting a bipolar ionizer in. So if I got a MERV 12, it may act like a MERV 15. If I got a MERV 8, I may get like MERV 12 type performance out of it by combining it with one of these ionizers. These ionizers are actually fairly simple. I got a couple different ones here. They have a couple different needles on there, and some of the needles are charging things positive, some of the needles are charging things negative. Bigger ones kind of do the same thing. I got 2 needles in this case. Airflow is going this way, charging some of the air molecules positive, charging some of the stuff in the air negative, and those things will later either clump to each other or they'll clump to other stuff in the space that already has charges. When you're installing these, it's actually quite simple. If you got a little one like this, you have a couple options on here, and there'll be a little arrow on here telling you which way airflow goes, but you can put it right on the blower housing, or if you wanted to, you could put it down here on the base. Same idea with these bigger ones. These are both magnetic ones, which is nice for an installation standpoint, because I don't really want to screw into the cabinet if I can avoid it. This one here would be pretty tough to fit up on top, but I could put him down here on the bottom and have the airflow coming in this way and going across him. The only key to installing any of these is that the airflow has to go across the needles like that, or on these needles this way and that way. I don't want the airflow to go through one and then the other. I want some stuff positive, some stuff negative. So if that's my fan and it's sucking the air in, I need the airflow to be going this way. So this guy needs to be installed in this fashion. Now, if I did put it up here, which I could do, I'd have to be pretty smart because I don't want these wires getting stuck in this belt. So on a really small unit like this, it'd be hard to put it on the actual housing. I'd have to put it upside down and I'd have to secure the wires so they're not actually touching it. Right? On a big rooftop, that'll be easier. On a small rooftop, it'll be tougher. So I probably will put it down here on something like that. Let the air come in this way, go across the two needles. In this case, this one actually has a self-cleaning device on it. This little helicopter blade, if you will, actually rotates once a day and just brushes those little needles off so you don't ever have to clean them. So there's a small moving part in here, right? But this guy will send ions into the space and make my filter do a better job. So there are ways to improve it if you can't get thicker filters in there. Well, thank you for joining us on this video today. Hopefully this helps you determine when to change your current filters and what kind of filters you might be able to upgrade to help your occupants out better. This is part of a continuing series that we have, so be sure to check out our other videos on rooftop units. Thanks for joining us.